So rapid sensory techniques. No, okay, we'll go to normal pace. That'll be silly to do it quickly. Okay, rapid sensory techniques. These are relatively new methods. Here, rapid refers to their use with untrained assessors and the relative quickness of doing the assessment. They generally need some quite sophisticated statistical analysis, however, using specialist tools like SPS, and we'll have a look at one of the methods a bit later on. Okay, so traditional versus rapid sensory. These are characteristics of traditional methods. Again, you can pause the video if you need to. These will continue to be the main approaches taken in sensory evaluation, but rapid sensory methods are growing more importance, and they're certainly a big topic of interest in terms of research in sensory methods. The time taken for traditional methods is a key issue, and also the training is often needed of panelists, and that's why more rapid methods have been developed. Rapid methods are quicker and easier from the perspective of carrying out the test. The analysis is, as I said, more complicated. Listed here we have some of the more widely used rapid techniques. We've done quite a lot of work on the technique called napping, of which more in a little while. Okay, so some rapid sensory methods. Napping is from the French word for tablecloth. Here assessors take samples and place them in a grid such that samples that are considered to be similar are grouped together, and those that differ are placed further away in the grid, though possibly close to each other. Principal component analysis is used for the analysis. I'm going to go into some statistical jargon here. PCA is a dimensionality reduction method. Is often used to reduce the dimensionality of large data sets by transforming a large set of variables into a smaller one that still contains most of the information in the large data set. Okay, deep breath. Essentially, this means the process simplifies a complex data set by focusing on the most important differences in the data. This happens in the statistical background. How it does this is complicated. However, the output is normally a graph which is much easier to interpret. I've got a good example of it done by a student project a little bit later on. Okay, so the first visit is someone else's efforts, and it's not a particularly helpful video explaining how napping works. The other video here was done as part of a student team project, and they are much better. See also the swear linked here on a walkthrough of the SPS analysis, which you'll discover is quite a bit of a process. It's multi-step, and you need to do a lot of little things before you get any answers out of it. This is really just reiterates what I've said before, and those of you who did this in the lab as part of the masterclass are familiar with how the method works. But to reiterate, we start with randomly numbered samples, in this case chocolate milk. Assessors place them in the grid as discussed earlier. They may also add comments, although that's outside the scope of this discussion. The data is recorded in the grid, and that information is transferred into Excel in a format like this, and then that is uploaded into SPSS. Here's part of the output from SPSS, a plot of the data based on coordinates provided by assessors. It's not very useful in itself. However, the next step, the group scatter plot, is actually what we need. This is from a student project done last year. We can see some pretty good grouping for the three samples here, grouped together by the various different coloured arrows, indicating the assessors could tell them apart effectively. This is a very good result. I was very pleased with this. So the methods. Descriptive analysis uses panelists that are trained to detect and describe differences among products. The panelists must be able to indicate which sensory attributes are present in a product and able to measure the intensity of those attributes. A range of methods are available here, some of which, such as flash profiling, are discussed briefly here. And again, in every page there's a link to the SSP, which goes into much more detail. I'm just doing a brief summary here. So for flash profiling, here untrained subjects select their own terms and describe and evaluate a set of products simultaneously, and then rank the products for each attribute they individually create. The method's rapid and does not need trained assessors. Again, it needs sophisticated statistical analysis, and it's something we'd like to certainly look at in the future. Free choice profiling. Here assessors are asked to identify both attributes in the sample and rate liking or intensity of those attributes. So this requires more training of flash profiling, and yet again needs sophisticated statistical analysis. Okay, that's all folks. Thanks for listening.